Welcome, everyone. I'm Pierre-Luc Delagrave, Technical Product Manager, and I'm with Kevin Green, Technical Expert specialized in reverse engineering here at Faro Creaform. Today, we'll talk about how to master the product development with the complete Scan-to-CAD workflow. All right, so now you may ask yourself, what is Faro Creaform role in the 3D scanning world for someone like you? Actually, we're here to address real-world problems. We support engineers, designers, and manufacturers so they can innovate faster and with confidence. Our goal is to remove the complexity from measurements and offer a fully integrated 3D scanning and modeling ecosystem that makes the scan-to-CAD process simple and efficient. Design and production should never be limited by measurements complexity or accuracy constraints. In this presentation, we'll start with the main challenges faced in product development. Then I'll introduce the solutions we offer for reverse engineering, and we'll look at a really interesting customer story. And finally, we'll walk through a complete Scan-to-CAD demo. If you've got any question, do not hesitate to ask them directly in the chat box at any moment, and we'll make sure to answer them during the Q&A session at the end. Let's start with the challenges most people face in the product development. Complexity of the project, the time from measurements to the final design, and the integration within the manufacturing process are important criteria to consider when selecting a solution for reverse engineering. These common challenges apply for the main application related to product development. Reverse engineering often feels more complex than it should. First, the limitation of current technology and methods make it difficult to work with some parts. Complex geometry reconstruction remains a major challenge, and inaccurate scan data makes CAD modeling even harder. Then, the user experience is also important. Many tools require significant expertise just to get started. At best, you want a measuring system that new user can pick up quickly without extensive training. Unfortunately, the user interface in many solutions add friction instead of streamlining the workflow. Productivity is a critical factor, and one of the biggest pain points in reverse engineering is simply the time required to complete the full workflow. Delays occur at every stage. The acquisition and processing of the high-resolution scan generate large datasets, and the extraction of features, cross-sections, or primitive can be slow when the tools aren't well suited for the task. Modeling parts requires numerous manual operations, and with an intuitive, easy-to-use function, the entire reverse engineering process slows down. When data isn't clean or tools aren't optimized, valuable time is lost, extending project timelines. Even with clean data and a finished model, integration remains a challenge. Most native CAD systems aren't built to handle large 3D scan datasets efficiently. Moving data into platforms like SolidWorks is rarely seamless and often requires repeated back and forth between scan and CAD software. The reality often involves manual adjustment, plugins, or workaround workflows. User expects their Scan-to-CAD tools to integrate smoothly into their existing software ecosystems so they can move between steps without disruption. Let's stop talking about challenges and focus on solutions. Let me present you the HandySCAN PRO series. We'll take a look at its key features and benefits it brings and show you how it perfectly fits for the product development. We call the HandySCAN Pro the ultimate solution for product development and reverse engineering. It is built specifically for engineer professionals who need to improve their workflow, accelerate times to market, and reduce development costs. And to make it a truly complete solution, we've paired the scanner with the Scan-to-CAD Pro software, all at a competitive price of $25,000 US. This combination delivers unmatched value and performance. Let me show you some of the benefits. The Pro is about 1.5 times faster than the previous generation, as we added more laser lines. This speed improvement means you can capture more data, which leads to better scan quality and also make it easier to scan at higher resolutions. Talking about higher resolutions, we've also made big improvements on the level of detail you can get. The HandySCAN Pro can reach 0.1 millimeter of resolutions. This means incredible details, even for your smaller, fine detail part. Look, the scanner is great, but the best in the software is the Scan-to-CAD Pro software that is included with it. This software is specialized to extract data from 3D scans. You can best fit entities in no time, align your part with confidence, create precise sketches with ease, and validate your modeling design with real-time CAD model deviation analysis. You can export your CAD model directly, or, if you prefer, you can also transfer the parametric timeline to SolidWorks to continue your design or create assemblies. We'll show you a complete demo soon, but just before that, I'd like to share a great customer story with you, one that actually appears in our product video. It comes from a mechanic shop that truly redefines perfections, EP9 Autosports. And I want to show you how 3D scanning has transformed their day-to-day work. Before we dive deeper, let's take a look at the section of the product video that relates to their story for those who haven't seen it yet. All right. All right. So the real story behind this video starts with a Pro 2 racer who felt that the existing exhaust manifold was holding back performance. EP9 was challenged to redesign the manifold under strict racing regulations where both accuracy and speed were absolutely critical. Before using a 3D scanner, EP9 relied on traditional methods. These approaches were slow and involved a lot of guesswork, which meant plenty of back and forth before getting it right. With the HandySCAN Pro in hand, the first step was to scan the engine heads to make sure that the new manifold will fit perfectly. The square exhaust ports needed to be connected into round header tubes, and having an accurate cross-section made the sketching process much easier. This ensured a precise fit with the existing parts right from the start. The team then used a modular plastic kit to manually route the runners, defining the overall shapes and positioning them to visualize the most efficient flow path. They also ensure all four pipes maintain identical lengths for optimal engine performance. Using Scan-to-CAD Pro, the design team was able to extract the center lines of the pipes and directly sketch and model the new manifold on top of the scan modular kit data, streamlining the transition from the physical mock-up to a precise digital design. So, what was the outcome? With the HandySCAN Pro and Scan-to-CAD Pro, EP9 was able to move from concept to finished solution quickly while maintaining accuracy, fit, and performance. And with the parametric transfer into SolidWorks, the engineers could easily refine and edit feature-based models directly in the CAD environment they already know and trust. Before, getting a functional prototype could take months of back and forth. Now, with our solution, we can go from scan to CAD to a 3D printed prototype in just one day. From there, it's only required a final ceramic coating and installation of the new manifold. What once took months can now be done in a matter of days. A real game changer for an ambitious teams competing in the demanding world of motorsports. EP9's success story really highlights what Faro Creaform is all about, turning uncertainty into confidence and accelerating innovations. This solution didn't just provide better tools, it helps shift the entire approach, moving away from trial and error towards a truly data-driven design process. With that, I'll now pass over to my colleague Kevin to continue the presentation.
Hey, thank you, Pierre-Luc. Uh, Hello, everybody. My name is Kevin Green, technical expert in the product management team at Faro Careerform, and I will be covering this complete workflow in the next couple of slides, from scan all the way to a complete transfer to SolidWorks. To begin, let's look at this part story. This simple part has had its CAD file lost through the years. The toolpath for the machining exists, but has flaws, and modifications need to be made to address new requirements. To recreate this CAD file, we'll go through the following steps, which you can see on the screen. To be fully transparent, this isn't an actual use case, but everything around it is. Our goal is for you to understand what a typical workflow would look like with a simple part, so you can relate all these steps to your more complex everyday job. Let's look at this workflow together. This small machine part is pretty reflective, and we can see that the HandySCAN Pro has no issue whatsoever to scan it. Our setup includes a turntable to facilitate the scanning process, and you can notice the colored laser lines which act as a distance meter. Following the scan, it's a one-click remove background. Then, second side scan with a quick cleanup, and we're already in the registration process. Again, this is a one-click process where the software uses the common targets to align both scans. Once aligned, it's a one-click merge function. This scan was performed at 0.4 millimeter resolution, and we can quickly see here that our multi-resolution function used 0.2 millimeter triangles on higher curvature areas. I want to put emphasis on the last part of this video, as we have, again, a one-click transfer to Scan-to-CAD Pro. Same environment for the user, quick and effective. Powerful tools like Clean Mesh function will help prepare the mesh for our modeling by correcting faulty triangles and filling small holes. Once this is done, we are at our most important step, which is mesh alignment. Using your Quick Entities tool, you are one click away from creating a geometry to align the origin to. In this case, our primary geometry will be the bore, as the orientation and distance from the backing plate is important. Then, the back face of the bracket, and finally, I created an average plane to block all degrees of freedom. In the Align tool, you can interactively change which geometry is used first, and look at the deviation impacts between the constraints. All this in a one table glance. To start off, we'll use our mesh to create a mesh sketch of the overall shape of the part. Using the auto sketch function, we can get a quick layout and we can delete unwanted areas. Once I completed those areas, I used tools like corner trim and add constraints to make sure everything was square and true through the cross section. We are proud to have a complete constraints tool, which is very user friendly. You can see from the video how easily I can add these constraints. Once my sketch completed, a simple extrusion with a click on the vertex I want the extrusion to stop at. Then another sketch to remove some more material. Convert primitives can be a useful tool to make sure our lines are in line with existing CAD. To create the vertical line, I use our integrated selection tools to perform a one-click best fit. Then, I use simple tools like resize and trim to complete my sketch. Once the outline done, I use an extrude cut in both directions to get rid of unwanted material. Onto another sketch we will use to cut out the cavity. Again, using the auto sketch, I get the majority of my lines and arcs, getting rid of what I don't like. Corner trim is a great tool to make sure you get those nice radii where lines meet other lines or arcs. Then I use our constraints tool to make sure my lines are tangent to my arcs. Once my sketch is done, I can compare it using the compare tool, setting my color map and changing my vector multiplier, ensuring the sketch reflects the actual part. Using my previous sketch, I use an extrude cut to create the cavity. I then use the compare tool to make sure deviations are within my range. I have been designing only half of the part, as I will be using the mirror tool to create the second half. I select the item I want to mirror, followed by the mirroring plane. We are now pretty close to our final design. I used our quick primitives tool, making sure the constraint to nearest axis is checked to generate cylinders which will be used to cut out our bores. I could have created a sketch instead and make sure both my holes are concentric, but the goal here was to show you how easy it was and efficient the function was. Once I am satisfied with the creation, I use the Boolean functions to remove the material. Then, I added some chamfers to the holes to make sure that the shaft being inserted will be guided. Finally, I do a quick color map to make sure everything is in order and use the direct transfer to SolidWorks. This will transfer our complete design tree, including the sketches. You will see in a few seconds that if I try to edit a sketch, even our 2D constraints had followed. Even if we have all the main tools for designing, the transfer to SolidWorks is useful for either assemblies or even 2D drawings. Scan-to-CAD Pro's main assets are leveraging your scans, which are precise measurements, but also simplifying your reverse engineering workflow. Now, let's do a quick return on benefits of this solution. Well, around 75% of the time spent converting a physical object to a CAD model is done in the software. That's why efficiency is so important. With Scan-to-CAD Pro, we can create the CAD model directly inside our software. No need to switch platforms or use external tools. This saves time, makes the workflow smoother and more reliable. And we haven't talked about how smooth the learning curve is. I have included our actual times for our two segments. Our previous videos have been slightly accelerated and edited to make sure you have the key information. In conclusion, without being 100% efficient, we completed this part in under half an hour, which is pretty impressive. Having scanning and modeling in the same environment makes everything simpler and more efficient. You get one workflow from scan to CAD, making the process intuitive and consistent. You have one learning curve, so new users can ramp up quickly and confidently. You work with one data set, which means no need to export or import files and no risk of misalignment. It's a streamlined product development process, which guarantees perfect fit the first time. And all of this comes at a competitive price of roughly 25,000 US dollars. That's why the HandySCAN Pro is the best offer on the market for Scan-to-CAD applications, from point A to point Z in one solution. And at this price, you get the best customer experience possible with an easy to use scanner as well as software. We have free onboarding courses, which will guide you through the best scanning practices, paired with many tutorials, which help you dig into our numerous functions and how to use them. But the customer experience doesn't stop there, as we have scanner and software support worldwide. If our integrated tooltips and or interactive help user manual can help you, you are one call or email away from support. I hope our webinar was resourceful and answered any questions you had about our solutions. If not, Pierre-Luc and I are available for your questions.
All right. Thank you, Pierre-Luc. Thank you, Kevin. Thank you very much for your time, your explanation. It was very clear. I hope it was clear for our viewers as well. My name is Jérôme Alexandre Lavoie. I'm one of the director of product management here. I focus on the 3D scanning segment of the Faro Creaform company. We are going to start our Q&A session, and I'll be the host for this period of time. For this section of the webinar, we already have a few questions that came in, but like Pierre-Luc mentioned before at the beginning of the presentation, you can use a question panel to send us more questions that it will be our pleasure to answer if the times allows it. So the first question we have is for you, Kevin. Can you expand a little bit more on the modeling function? Do we have all the Do we have all the functions? Do we have the complete toolkit, or are we still missing some function for the modeling operations?
To this day, no, but the lofting and sweep functions are scheduled to be released in the upcoming months. Once we have those two functions, I would say we can consider ourselves a complete CAD solution.
All right, and there's two questions that are related about the live transfer. So basically, the first question is, do we have other live transfer or direct transfer other than SolidWorks? And the second question is, if the answer is no, what's the process to work with other CAD platform to complete the reverse engineering process?
So to start with, we only support SolidWorks to transfer the design tree directly. We do still support the transfer of entities to like Fusion 360, Solid Edge, etc. But the design tree is only with SolidWorks. Now, if you want to continue your design in another CAD software, it's possible to either export the sketch as an IGES or a step file, and or the CAD model as a step or an IGES file and import it into your CAD software.
All right, so through step and IGES file and then export, import, perfect. Pierre-Luc, maybe you can answer a little question about the accuracy of the scanner, the HandySCAN Pro accuracy. What is the exact specification?
Right. Accuracy wise, the how does it work is we have two specs for accuracy. The first one is what we call the local accuracy, and this value is 30 microns. And basically, the local accuracy is the spec within a static field of view of the scanner. So basically, if you put a small part on a turntable, that will be the field of view of the scanner, and this accuracy is about 30 microns. The second spec of accuracy is what we call the volumetric accuracy. So if you're doing bigger parts, you have to travel with your scanner to capture all the data. And we've got a spec that says that we've got 20 microns plus 60 micron per meters. So for example, if you've got a 2-meter part, you will have 60 times 2, so 120 plus 20. So it will end up to have a volumetric accuracy about 140 microns for a 2-meter part.
Following that topic, Pierre-Luc, we have a question about the limits in terms of part size range. So the question is, what's the largest size part that can be scanned with the scanner? Would this scanner be practical to scan a semi-trailer or shipping container? So
Well,
I'll let you answer this one.
all right. So the recommended size, part size is up to 4 meters. So you can do really small parts like 5 centimeter, but we recommend to use it as 4 meter parts. And it's mainly depending on the scan resolution, so the level of detail, the size of the triangle that you will put. So at some point, if you scan really big parts, the files will become really heavy. And also for really big trailers, the volumetric accuracy actually get bigger and bigger. So you could always do bigger parts depending on your needs and the tolerance and the accuracy needed, but you will have probably to do a little bit of a workflow. So scan the target first, or maybe do separate scan, and after that best fit them with a merging function. But we also have, like, if you're doing bigger part, we have the other scanners like the HandySCAN Max, which is done for bigger parts, go faster, also more accurate. So always depending on your need, but it's doable. But yeah, maybe not recommended to be really, really big, but it can be done.
Yeah, I'm putting right now the link to the HandySCAN Max, which I feel would be much more suitable in terms of practicality for this type of application. So you can check out the link in the chat. It will tell you more about the HandySCAN Max product line. The HandySCAN Max product line outputs an STL file which can be directly imported into the Scan-to-CAD platform. From there, you can do exactly what Pierre-Luc and Kevin showed you
I
earlier.
think you put the link on only to the organizer.
Francis just sorry,
I just
but
did it. All right.
we
Perfect.
just reposted it, so you
Perfect.
should have access to the link. Quick question, and I'll come back to Kevin because we have question about Scan-to-CAD versus Scan-to-CAD Pro. Um, can you confirm that you need Scan-to-CAD Pro to convert the scan into a solid model? Because the Scan-to-CAD software can only export uh, IGS file and features that you have created or sketches that you have created. Can you? I think it would be great to differentiate the Scan-to-CAD software and the Scan-to-CAD Pro software.
So for Scan-to-CAD, you can create, think of it as creating references that you will be using afterwards in a CAD software. Can you create a solid kind of with the auto surface function, which you will export as an IGES, and if it is watertight, the part will import as a solid model in your other CAD software. Now the difference is with Scan-to-CAD Pro, you can create a parametric solid with a sketch. So put defined, distances or constraints or whatsoever, and you end up with a parametric solid at the end, which is exportable either IGES step file or even STL for 3D printing, and or you can transfer the complete design tree in SolidWorks where you can modify your steps or I don't know, complete your design with a 2D drawing for machining or whatever. Hope this answers your question.
Thank you. We have another question. We already answered this one. Will we be able to export the full Model 3 and sketches to Creo? Currently, the answer is no. You would have to go through the export of the IGES
Yeah.
and step file to work with this software. Will we ever be able to do that? Well, we'll see in the product roadmap. We have different priorities right now. And obviously, we would like to do everything, but we have to make some choices from time to time, unfortunately. Pierre-Luc, Uh, Scanner related question. Does it always need targets to scan? Maybe you can give a broader answer about the complete portfolio. I mean, start with the HandySCAN Pro, but after that, you can talk about all the handheld 3D scanners that we have at Creaform.
Right. So the answer is yes, you need to have some targets to use for HandySCAN product line, so which include the HandySCAN Pro, the HandySCAN Black, the new HandySCAN Evo, and also the HandySCAN Max. One of the scanner that doesn't require targets is what we call the GoScan Spark, which basically position the scanner itself with geometry. You can also use targets if you have lack of geometry. You can put some targets, but this GoScan Spark is probably the one that you're looking for. We also have our high-end product, the MetraScan, which is mainly targetless, meaning that you have to put a few targets around the part, and you have a scanner that will be recognized by what we call a C-track that will just locate the scanner. If you've seen it before, it's like the big round spheres with a lot of targets on it. So this target is mainly targetless. So probably if you, what you have in mind is probably a targetless scanner will be our GoScan Spark solution.
Yeah, I feel like for reverse engineering, I mean, the GoScan Spark, if we're talking about a relatively small part, meter and a half, 2 meter, less than 2 meters, the GoScan Spark can do a fantastic job if you have enough geometry or texture to um, enable the scanner to find its space, find its position in space, and keep the tracking along the entire scanning process. Like Pierre-Luc mentioned, we can also put some targets to help in different situations where there's a lack of geometry or texture. Um, there might be also, depending if the part is big enough, we have two models of the HandySCAN Max. One that is more positioned towards the product development and reverse engineering. That can be interesting. As for the MetraScan, it is truly a
High-end product.
targetless type of scanner, meaning that you don't have to put any targets on the part. If you do want to compensate for flow vibration, yes, you can put targets on a fixture. But the MetraScan basic positioning, or the reason why the MetraScan exists, is to deliver to our customer, our quality control customer, uncompromising accuracy, trust, high repeatability. So this is really for typical quality control in production type of application, and it's a much more high-end product in terms of capabilities, accuracy, resolution than the GoScan or the HandySCAN Max, but it comes also at a higher price point. Um, we have one question left. If we are scanning an assembly, are we able to get different parts from one assembly? So I'm not quite sure if I understand correctly the question. So let's say you scan multiple part of an assembly, Kevin.
Well, there's
Um,
always the way
how
I
would you do
understand it
that?
is, yeah, the way I understand that is, let's say you'd have let's say for example, a motorcycle. There's always a way you can put targets, scan your overall motorcycle, take a piece of fairing off, continue your scan. So you scan the complete fairing, do the these steps with all the parts you want to disassemble, and in the software afterwards you will have your scan assembled, and you can hide the fairing and still have the motorcycle there. So I don't know if that, yes, it's a possibility. A little bit trickier for new users, but yes, there's a certain workflow you can do to be able to to end up with your assembly.
All right. Hope this answers the question. Thank you very much, Kevin. Thank you very much, Pierre-Luc. This was the last question we have received so far. I want to thank you everyone for your attention. If you do have any more questions that pops in your head in the next hours, days, or weeks, feel free to contact us. It will be our pleasure to take the time with you to discuss your application and answer all of your questions. Big thank you again to you, Pierre-Luc and Kevin. You made this presentation very interesting. To everyone, I will see you again on the next webinar. Thank you very much and have a good day.
Thank you,
Thank
everybody.
you.